As the electrical contractor, the company bears ultimate responsibility for the electrical work performed in the X-ray room. This responsibility extends to ensuring compliance with all applicable codes and standards, encompassing the installation and operation of both the X-ray equipment and its associated electrical systems. Job approval hinges on inspection by the local authority having jurisdiction, referred to as the AHJ. Should the AHJ identify any code violations or safety concerns, the job may face rejection. It is crucial to acknowledge that the X-ray equipment, along with its installation, is also subject to inspection and approval by a separate regulatory agency, such as the Food and Drug Administration or a state radiation control agency. The conduct of the X-ray technician, while professional and unacceptable, does not automatically translate into specific code violations or safety concerns based solely on their behavior. However, if their actions lead to tangible violations, meticulous documentation and reporting to the AHJ become imperative. There are several responsibilities in this situation. Firstly, meticulously document any code violations or safety concerns that are observed. Secondly, communicate these findings to both the contractor and the customer involved. Thirdly, request that the X-ray technician rectify any identified deficiencies. Fourthly, conduct a thorough inspection of the completed work to guarantee compliance with all relevant codes and standards. Fifthly, promptly inform the AHJ of any concerns that may arise regarding the installation. It's important to understand that there is a right to inspect the work of other contractors on the job site, including the X-ray technician. This prerogative ensures that their work doesn't compromise the safety or integrity of the electrical work being undertaken. Special attention should be given to cable splicing. It is essential to ensure that cable splicing is executed properly, employing an approved method and materials. Request comprehensive documentation from the X-ray technician detailing the splicing method utilized, and conduct a meticulous inspection of the splice before energizing the circuit. In conclusion, addressing these issues promptly and professionally is of paramount importance. Clearly communicate concerns to the contractor and customer, and diligently document any code violations or safety hazards encountered. Collaborate closely with the AHJ to ensure that the job adheres to all applicable requirements. By proactively adopting these measures, the company can safeguard its liability and uphold the safety and compliance of the X-ray installation. For a deeper dive into electrical safety and compliance, let's explore some fundamental concepts and relevant regulations. Electrical safety in healthcare facilities is paramount due to the sensitive nature of medical equipment and the vulnerability of patients. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, addressing specific requirements for healthcare facilities in Article 517. This article covers essential electrical systems, general care areas, critical care areas, and wet locations, among other aspects. The NEC mandates that healthcare facilities have essential electrical systems designed to maintain power to critical areas during power outages. These systems typically consist of two independent power sources: a normal source, usually the utility company, and an alternate source, such as generators or batteries. The essential electrical system is divided into three branches: life safety, critical, and equipment. The life safety branch powers essential functions such as emergency lighting, fire detection, and alarm systems. The critical branch supplies power to critical care areas, operating rooms, and other areas where interruption of power could jeopardize patient safety. The equipment branch serves equipment necessary for patient care and support, such as heating, ventilation, and air conditioning systems. Grounding and bonding are crucial for electrical safety in healthcare facilities. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. Bonding ensures that all metal parts of the electrical system are electrically connected, minimizing voltage differences and reducing the risk of shock. Article 517.13 of the NEC specifies the grounding requirements for patient care areas, requiring that all exposed metal surfaces be grounded to a common grounding point. Isolated power systems are often used in critical care areas and operating rooms to provide an additional layer of protection against electrical shock. These systems use an isolation transformer to isolate the electrical circuits from ground, reducing the potential for ground faults and minimizing leakage current. A line isolation monitor, or LIM, continuously monitors the impedance from each line of the isolated power system to ground. If the impedance falls below a certain threshold, indicating a potential ground fault, the LIM will alarm, alerting personnel to the problem. Regular testing and maintenance of electrical systems are essential to ensure their continued safety and reliability. The NEC requires periodic testing of emergency power systems, including generators and automatic transfer switches, to verify their proper operation. Grounding and bonding systems should also be inspected and tested regularly to ensure their effectiveness. Healthcare facilities must comply with various regulatory requirements related to electrical safety, including those set forth by the Joint Commission, the Centers for Medicare and Medicaid Services, or CMS, and state and local authorities. The Joint Commission, for example, requires healthcare organizations to have a comprehensive electrical safety program that includes policies and procedures for electrical safety, training for personnel, and regular inspections and maintenance of electrical systems. CMS also has specific requirements for electrical safety in healthcare facilities, particularly regarding the essential electrical system. Failure to comply with these regulatory requirements can result in fines, loss of accreditation, or other penalties. Now, let's address the specific concerns raised regarding the X-ray room wiring. The X-ray equipment typically requires a dedicated electrical circuit with specific voltage and amperage requirements. The manufacturer's specifications should be carefully followed when installing the electrical supply to the equipment. It's crucial to ensure that the circuit breaker or fuse protecting the X-ray equipment is properly sized to prevent overloads or short circuits. The wiring method used to supply power to the X-ray equipment should comply with the NEC and any applicable local codes. Typically, rigid metal conduit, intermediate metal conduit, or electrical metallic tubing is used to provide physical protection for the conductors. The conductor should be sized appropriately for the load and the length of the run to minimize voltage drop. X-ray equipment often generates electromagnetic interference, or EMI, which can affect the performance of other electronic equipment. Shielded cables and proper grounding techniques can help to minimize EMI. The NEC requires that electrical equipment be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all, to ensure that it meets safety standards. The X-ray equipment should have a UL listing mark or other approved certification mark. The X-ray technician's conduct, while unprofessional, should not be the primary focus. Instead, focus on the technical aspects of the installation and whether they comply with codes and standards. If the X-ray technician's actions result in code violations or safety concerns, document these issues and bring them to the attention of the contractor, the customer, and the AHJ. The fact that the supplied power cable was too short and the X-ray technicians are planning to splice it raises several concerns. Splicing cables is generally discouraged, especially for high current or critical circuits. If splicing is necessary, it should be done using an approved method and materials. The splice should be mechanically and electrically sound and should be properly insulated. The splicing method should be suitable for the type of cable and the environment in which it is installed. The NEC provides guidelines for splicing conductors in section 110.14. If the X-ray technicians are using a different type of cable for the splice, this could create additional problems. Different types of cables may have different insulation properties, current carrying capacities, and voltage ratings. Using dissimilar cables in a splice could result in overheating, insulation breakdown, or other failures. It's important to inspect the splice carefully before energizing the circuit to ensure that it is done properly and that the cables are compatible. The right to inspect the work of other contractors on the job site is crucial, especially when their work could affect the safety or integrity of the electrical installation. As the electrical contractor, you have a responsibility to ensure that all electrical work on the job site complies with codes and standards. If you have concerns about the X-ray technician's work, you have the right to demand to inspect it. If the X-ray technicians refuse to allow you to inspect their work, you should notify the contractor, the customer, and the AHJ. The local AHJ has the final authority to approve or reject the electrical installation. If the AHJ finds any code violations or safety concerns, they can require that the work be corrected before the job is approved. It's important to work closely with the AHJ throughout the project to ensure that the electrical installation meets all applicable requirements. The permit in the job typically covers all electrical work, including the X-ray equipment. However, it's important to verify this with the AHJ to ensure that there are no separate permitting requirements for the X-ray equipment. In addition to the NEC, there may be other applicable codes and standards, such as those related to radiation safety. The X-ray equipment must comply with all applicable radiation safety regulations. Consulting with a qualified radiation safety expert can help to ensure compliance. To further clarify the requirements, let's delve into specific NEC articles relevant to the situation. Article 300 addresses wiring methods, emphasizing the importance of proper installation techniques and protection of conductors. Section 300.4, for example, covers protection against physical damage, requiring that conductors be protected from abrasion, nicks, and other damage during installation and operation. Article 310 covers conductors for general wiring, providing detailed information on conductor ampacity, insulation types, and installation requirements. Table 310.15b16 provides ampacity ratings for various conductor sizes and insulation types, taking into account factors such as ambient temperature and the number of conductors in a raceway. Article 400 covers flexible cords and cables, specifying the types of cords and cables that are permitted for various applications. Flexible cords and cables should be used only for pendant wiring, wiring of fixtures, or other applications where flexibility is required. They should not be used as a substitute for fixed wiring. Article 517, as mentioned earlier, provides specific requirements for healthcare facilities, addressing essential electrical systems, grounding and bonding, isolated power systems, and other aspects of electrical safety. Section 517.13, for example, specifies the grounding requirements for patient care areas, requiring that all exposed metal surfaces be grounded to a common grounding point. Article 600 covers electric signs and outline lighting, providing requirements for the installation, wiring, and control of signs and outline lighting systems. The X-ray in use sign may be subject to these requirements. Article 700 covers emergency systems, providing requirements for the installation, testing, and maintenance of emergency power systems. The essential electrical system in a healthcare facility is subject to these requirements. In addition to these NEC articles, there may be other applicable codes and standards, such as those related to fire safety, building construction, and accessibility. It's important to consult with the AHJ to determine all applicable requirements. Let's explore some practical steps to address the situation. Firstly, conduct a thorough inspection of the X-ray room wiring, documenting any code violations or safety concerns that are observed. Take photographs or videos to provide visual evidence of the issues. Secondly, communicate your findings to the contractor and the customer, explaining the potential risks and liabilities associated with the code violations. Put your concerns in writing to create a record of your communication. Thirdly, request that the X-ray technicians correct any deficiencies, providing them with specific instructions on how to bring the installation into compliance with codes and standards. Set a reasonable deadline for the corrections to be completed. Fourthly, inspect the completed work to ensure that all deficiencies have been corrected and that the installation meets all applicable requirements. If you are not satisfied with the work, notify the contractor, the customer, and the AHJ. Fifthly, inform the AHJ of any concerns that you have about the installation, providing them with all relevant documentation and evidence. Request that the AHJ conduct an inspection of the X-ray room wiring. Sixthly, work closely with the AHJ to resolve any issues and ensure that the electrical installation meets all applicable requirements. Be prepared to provide additional information or documentation as needed. Seventhly, document all of your actions and communications related to the X-ray room wiring. Keep a record of all inspections, meetings, phone calls, and emails. This documentation will be valuable in protecting your company's liability. Regarding the splicing of the cable, consider the following. Obtain documentation from the X-ray technicians on the method they use to splice the cable, including the type of connectors, the insulation material, and the splicing procedure. Inspect the splice to ensure that it is mechanically and electrically sound and that it is properly insulated. Verify that the splicing method is suitable for the type of cable and the environment in which it is installed. If you have any doubts about the safety or reliability of the splice, recommend that the cable be replaced with a single, continuous length of cable. Concerning the different type of cable being used for the splice, determine the specifications of both cables, including the insulation type, the conductor material, the ampacity rating, and the voltage rating. Compare the specifications to ensure that the cables are compatible. If the cables are not compatible, recommend that the cable be replaced with a single continuous length of cable that meets the requirements of the X-ray equipment. When dealing with the X-ray in use sign, verify that the sign is properly installed and wired in accordance with the NEC and any applicable local codes. Ensure that the sign is clearly visible and that it is connected to a reliable power source. If the X-ray technician is not providing the 24 volts DC relay to turn the sign on and off, this may be a violation of the contract. Review the contract to determine who is responsible for providing the relay. If the contract requires the X-ray technician to provide the relay, demand that they do so. If the contract is unclear, negotiate with the contractor and the customer to determine who will provide the relay. Regarding the free air wiring of the 24 volts DC to the junction box, this may be a code violation. The NEC requires that conductors be protected from physical damage and that they be installed in a neat and workmanlike manner. Running individual conductors through free air to a junction box may not meet these requirements. Recommend that the conductors be installed in a conduit or other approved raceway. Always remember that safety is the top priority. If you have any concerns about the safety of the electrical installation, take immediate action to protect yourself and others. Energize the circuit if necessary and notify the appropriate authorities. Electrical work in healthcare facilities requires specialized knowledge and skills. If you are not qualified to perform the work, hire a qualified electrician. Continuous education and training are essential for staying up to date on the latest codes, standards, and technologies. Attend industry conferences, take online courses, and read trade publications to expand your knowledge and skills. By following these guidelines, you can help to ensure the safety and compliance of electrical installations in healthcare facilities.